So hi guys, today we are going to discuss about backtracking and it's a very easy topic, so I'll explain and so today we are going to discuss about backtracking and we will be using this problem over here, gendered parentheses problem, which I have explained in one of my videos. The problem requires us to generate a well-formed parentheses where we have been given only the number of pairs of parentheses that we can use. Now, I'll be drawing the recursion tree for n equal to 3, where n is the number of parenthesis pair, and I'll be showing you how we can make decisions based on given constraints. So let me just write down what we want. Generate well-formed parentheses given number of pairs of parentheses that we can use. Now I'll be doing it for n equal to 3 and you can do it for the others. I'll just explain you how to do it. So suppose we have been given n equal to 3, that means we have 3 pairs of parentheses, and the problem it involves only round parentheses, which is this. So we have 3 pairs, so that means we have 3 opening brackets and 3 closing brackets. And if I put it clearly, we will have 6 places in every string, and we will have decisions to make as to which bracket to put, and we can use only one bracket. We can use a bracket only once. 3, 4, 5 and 6. So we will have 6 places and we have to put a bracket accordingly so that we get a valid string. Now if you remember, or if you have not seen that video where I have solved the problem, I have observed, or let me do the observation again so this will be clear. So if you see, this is a well-formed parenthesis. So the observation that we make here is that the closing bracket cannot come before the opening bracket. If it comes, then it will be like this. That means it is not a valid parenthesis. So the first is closing bracket comes only after an opening. And the second observation that I want you guys to see is that, let's say we have something like this. Now if you can see, the number of opening brackets equal to the number of closing brackets. Now if I put a closing bracket over here, then no matter what bracket you put over after this, the entire string will never be valid. The reason is, for this closing bracket over here, you will never find an opening bracket before it, because this string is already balanced. So the observation that we make here is, we can only put closing bracket if the count of closing bracket in the string is less than opening bracket. So these were the observations that we did for the problem, but why this can be solved using recursion, that is the thing that we need to learn. So if you remember, there are certain data structures that can essentially be solved by solved by recursion, like trees and linked list and even stack. So we can use recursion to solve these kind of data structures. But what if there is a vague problem, there is an open problem, and we don't get identify, when we are not able to identify, how do we utilize recursion to solve this problem, or backtracking to solve this problem? then what should come to our mind is that backtracking is often used for problems it is asked where it is asked or to explore all possible solutions. So whenever something like this is asked, you should think about applying backtracking. And also backtracking involves certain choices that we are given, and certain decisions that we need to make, and based on that we need to find a solution. So if you can see, we have a choice whether to put an opening bracket or a closing bracket, and the constraints that we have are closing bracket should come only after an opening bracket, and we can only put a closing bracket if the count of closing bracket is less than opening bracket. So let's begin with this and let's draw the recursion tree to understand the problem better. So let's say we have n equal to 3, that means 3 opening brackets and 3 closing brackets. We start with an empty string, and the first bracket that we should put, given the two conditions that we have, is an opening bracket. Now why? Because we cannot put a closing bracket first, because the string is empty and there is no opening bracket. An opening bracket should come before closing bracket. So the first bracket that we can put is a closing bracket. So I'm putting a closing bracket over here. Till now the opening count is 3 and closing count is also 3. That means we have 3 brackets, opening brackets that we can use, and 3 closing brackets that we can use. Now don't get confused with the count in the string, because the second point, it discusses about the count of brackets in the string, and this is the count that we are left with. Now when we have added one opening bracket, the count that is remaining for opening bracket is 2, for closing it's still 3. Now we have to make a decision. There are two possible choices that we have. We can either append an opening bracket or we can append a closing bracket. Why we can append a closing bracket? Because inside the string, the count of closing brackets is less than opening bracket, and there is no closing bracket. So let's see. So the two possible paths that occur from this are this. So we have used 2 opening braces over here, brackets over here, so we are remaining with just 1. Closing is still 3. Now further down we will have multiple paths. I will draw all the paths that are coming out from this, and I will leave as an exercise for you guys to solve this. If you are not able to solve, let me know in the comments. I'll make a video on this also. But let's see. Now we have again 2 choices with us. We can either apply an opening bracket or we can apply a closing bracket. Let's explore both the choices. Here we have the opening count is 0 because we have exhausted all the opening brackets that were available for us. Closing is still 3. Opening is 1 over here and closing becomes 2 because we have used 1. Now let's explore what we can do from here. We have exhausted all the opening counts, so we cannot apply any more opening brackets. We will just keep on applying closing bracket thrice. So I'll just draw this. Here we have opening as 0, closing also as 0. This doesn't happen directly, don't forget. I'm just doing it for the sake of reaching out. I mean, because at the end it will result into this only. I'm skipping the steps in between. Actually, it will call the recursion again and again, at least 3 times. I mean, not at least, but yeah, exactly 3 times to append the closing brackets. So here we are not here we are exhausted all the closing and opening brackets, and we are remained with this. Now this is a valid string because we have exhausted the count that we had. This is one of the balanced string that we have because we have kept in mind the constraints and we have made the choices accordingly. Now let's explore what balanced strings we will get from here. We have one opening bracket remaining with us and 2 closing brackets. Again, there will be 2 possible conditions that we can form here. This is 1, The other one will be this. So here we have utilized two of each. So opening also is remaining, opening also is 1 and closing also is 1. Here we have utilized 3 opening brackets and 1 closing bracket. So opening becomes 0 and closing is 2. So let's see how it goes from here. Now as you can see, the number of opening brackets and closing brackets is same. So the second condition, if you remember, the closing bracket, let me just navigate to the second condition for you. We can only put closing bracket if the count of closing bracket is less than opening bracket. Let me mention in string as well. Strictly less. So you can see it is not strictly less. So we cannot apply a closing bracket. So we have only one choice that we can do. That is apply an opening bracket. So now we have exhausted all the opening brackets. We just are remaining with one closing bracket with us. Now we have two closing brackets that we can apply. So obviously there will be two recursive calls, and at the end we will have this. This is again a valid string. As you can see, for every opening bracket we have a corresponding closing bracket. The only step that remains over here is applying a closing bracket. So this is a valid string because we have reached the base case, which is opening equals to 0 and closing equals to 0. Basically we have exhausted all the available brackets that we had. Now this is again a valid string, this is a valid string. So we have developed 3 valid strings. I leave this part to you, but I want to explain to you one more thing. Like if you can see, the backtracking is, like I said, you have certain choices and you have to make decisions and then apply those decisions based on some constraints. So the decision that we had was to whether to apply an opening bracket or a closing bracket, and the constraints, we already had like 2 constraints with us. So yeah, based under those constraints you had to apply the brackets. There is some boilerplate code for, you can say, for backtracking, and I have shown that I've implemented this generate parentheses problem in the in the video that in which I'm solving the problem. I'll be linking the video in this in the description also, and you can find it on the screen also at the end of this video. So this is what backtracking is essentially. Whenever a problem is given to you, and if you can see, like, you can apply recursion into it or a backtracking into it, I would recommend that you draw the recursion tree and draw out all the possible combinations that you can and see that your constraints are fitting or not, and if they are, then just go ahead and use the boilerplate code and code your solution out. I'll be bringing more backtracking problems so that the concept of backtracking is made clear. This is all for this video. I'll be also putting the PDF of this in the description box. Feel free to download it and use it. Thank you.